All right. Hi, everybody. So in this lesson here, we're going to use the trigonometric ratios to find unknown angles. So our goal here, okay, is to find an angle in a triangle. Now, just like it says here, trigonometry is the study of triangles. It's the study of their lengths and their angles, okay, the relationships that exist in there, and kind of taking advantage of those relationships to find information that's not given to you. Now, and it is one of the most important fields of mathematics. I personally, I love teaching trigonometry. I love going over it with people. Um, it's such a big field of mathematics, but it all works together so beautifully. There's just so many neat things that you can see in the relationships that we uncover in trigonometry here. Um, Anyway, so the trig ratios are relationships between the sides of a triangle and the indicated acute angle here. It is based on the relative, okay, the relative labeling, oops, uh, that we looked at in a previous lesson. Okay, it's based on the relative labeling of a triangle. So when we start dealing with the trigonometric ratios, we mean that literally. We're talking about ratios of side lengths, okay? So the ratios here are side lengths, and there are three primary trig ratios that we look at. So we create this triangle right here off to the side, let's say. So there's our right angle. So and we're just going to pick one. Here's our theta. This is the angle that we're looking for, our reference angle here. So this is our hypotenuse. This is the side adjacent, and over here, this is the side opposite. Now, it turns out, regardless of how big the triangle is, that those ratios are always the same for a given angle. Doesn't matter how big the triangle is, okay? So just by way of an example here, for example, and this is one ratio that I know off the top of my head. If this is 30 degrees, okay, if this is 30 degrees, then I know that one possible relationship here is that this side, the opposite side, is 1 unit of length. The hypotenuse would therefore be 2. Okay? If this could even be a bigger triangle here, again, if this is still 30 degrees, let's say that this is now 2, turns out the hypotenuse is 4. Okay, that ratio of the side length stays the same. It could be even bigger here. You've got this 30-degree angle here. This would be 3. This would be 6. Okay, that relationship always holds. Now, we give the very specific ratios that pop out names. So we start off with the sine ratio. And the sine ratio is the ratio of the length of the side opposite the angle to the length of the hypotenuse. So for each of these, what I've done here essentially is giving you a sine. The sine of 30 degrees, it turns out, is the length of the opposite over the length of the hypotenuse, so 1 over 2. Doesn't matter how big the triangle is, doesn't matter how long those sides are, that ratio, if that's a 30-degree angle, will always be 1/2. The cosine ratio for an angle is going to be the length of the adjacent side, okay, to the hypotenuse, adjacent side to the hypotenuse. Now that's a little bit more complicated for 30 degrees, so I'm not going to go over that right now. But yeah, that's what we would do here. So the cosine ratio is always going to be that ratio of the length of the adjacent side to the hypotenuse. It doesn't matter how big the triangle is. All that matters is what the angle is. The angle determines what that ratio is going to be equal to. And that's important because that means I can use this for any size triangle. And then finally, the tangent ratio is when we take the opposite side and divide it by the adjacent side, the length of the opposite side divided by the adjacent side. And again, that ratio will always be the same depending on the angle that we're dealing with, not the size of the triangle. Cannot overemphasize that point. So when we're putting that together, to help you memorize that, we've got a kind of a goofy little way of memorizing it. We break this up into a little word here, and the word is Sohcahtoa. Okay, Sohcahtoa. And I'll sometimes see people write this on an exam or on a quiz just off to the side, so they help them remember this. Sohcahtoa. And the way that works is so is sine is the opposite divided by the hypotenuse. Cosine is the adjacent divided by the hypotenuse. Toa is tangent, is the opposite divided by the adjacent. Okay, so that's just a way of helping people memorize those relationships, those ratios, because you do need to have them memorized. You do need to know what they are. Okay, so now we're going to take a look at just some ways of applying these little ratios, applying this little bit of knowledge here. So in a little bit here, you're probably going to want to make sure you have a calculator handy to help yourself walk through this material. Okay, so the first thing we want to do here is make sure that we can understand what we mean when we ask you to find the ratio. Okay, so we've got these ratios that we've just identified here. Now I just want to get the ratio. I don't want to do anything with the ratio, I just want to get it. So we want to first of all find the tangent ratio for Z, angle Z. So that's this angle right here. Now, as soon as we identify that, we've identified a few things. Now, first of all, the hypotenuse is the hypotenuse. There's not much that's going to change here. But if Z is the angle that's of interest to us, then 40 here is the opposite, and 30 here is going to be the adjacent. Okay? So then the tangent of angle Z, I don't even know what angle Z is. Okay, I don't have to know what it is. Okay, I know that there's a very specific angle that is going to be created, though, if the sides are 30, 40, and 50 here. And I know that the tangent ratio is going to be the opposite over the adjacent. So in this case here, that is going to be 40 divided by 30, or 4/3 when I simplify that. If we were going to find the sine ratio, the sine of Z, and it looks like this, the sine of Z is going to equal the opposite over the hypotenuse. So in this case, the opposite is 40 and the hypotenuse is 50. And so again, when we simplify this, we get 4/5. And then finally, the cosine ratio, the cosine for Z is going to be the adjacent side divided by the hypotenuse. The adjacent side to Z is 30, the hypotenuse is 50. And so the cosine ratio for that would be 3 divided by 5. So, and again, if we were to focus on X, okay, if our focus had been on angle X, angle X, then those ratios would have been different. The sine, cosine, tan would have been different because the labeling would change relative to the angle that we're investigating or that's of interest to us. Okay, so now we're going to use some of the information that we've got here, and the tools that we've now uncovered here to find an acute angle in a triangle. Okay, and there are really two methods for this. We're going to break this up into these two methods here, but you might look at what I just said here and say, well, it's okay, it's great, it's wonderful that, for example, that the sine of 30 degrees is going to be 1/2. The opposite is 1. The hypotenuse is 2. So I would know, for example, if I had a triangle here and I knew that this was 5 and this was 10, I could tell you right away, because I've just seen it here, that I know that this is 30 degrees. The thing is, and you might rightly say, I didn't know prior to this video that if it was a 30-degree angle in a right triangle, that the opposite side would be 1/2 of the hypotenuse. You didn't know that. And that's a fair argument here. I mean, you don't know that. If this all of a sudden changed to 40 degrees, what would that ratio be? I mean, you don't know off the top of your head. But the calculator does know, and that's the issue here. These ratios are in, or the calculator has the ability to access these ratios here, so we can use the calculator to find that. Prior to there being a calculator, people had written out lists. There'd be charts with angles in there and their specific ratios with them. So the calculator just makes things a little bit easier for us. Now, on your calculator, you will have these buttons right here, sine, cos, and tangent. Here are your your trig buttons here. Now, these buttons, the way they sit, sine, cos, and tan, take an angle and produce a ratio. That isn't exactly what we want here. That's not what we're interested in. So I'm just going to erase that little bit here because I want you to look a little bit at these buttons again on your calculator and notice that just above those is a different symbol. And sine to the -1, cosine to the -1, and tangent to the -1 take a ratio. Whoops. Wow. Take. That was weird. They don't tank a ratio. They take a ratio and produce an angle. And that's what we want to look at right now. Okay, we want to take a ratio and produce an angle. So for example, if I was going to look for angle A, and let's say I had my triangle here, and here's angle A. I don't know what that is, but I do know that the side over here is 10 and the hypotenuse is 13. I would know that this statement is true. The sine of A is equal to 10 over 13. Now, I want to know what A is. So what I'm going to do is I'm actually going to use the sine to the -1 button of 10 over 13. So typically the way you access that is to press the second button, sine, and that opens up the sine to the -1. You would enter your 10 divided by 13, and then when you press enter, you should get that this is approximately 50.3 degrees. Okay. Let's say that you had your triangle here. Again, here's A. This time you notice that the adjacent side is 5 and the hypotenuse is 12. Okay, well that's a cosine ratio. If I know the adjacent side and I know the hypotenuse, that's the cosine ratio. So what I would do here is, and I'll change maybe colors here, I would press second cosine to access that inverse cosine function, what we call the inverse function. And that's going to produce for me the angle given that ratio. And that's going to be approximately 65.4 degrees. And now finally, let's say in our last triangle here, here's angle A. And I know that my tangent of A is 1/2. So basically what that means is I know that the side opposite A is 1, the side adjacent to A is 2. Opposite over adjacent. So if I wanted to figure out what A was, it would be what we call the inverse tangent. So what I would do here, and I'll just do it in, I'll do it in red here. So I would press second tangent and then enter that ratio there, 1/2. And when I do that, I get that the angle is going to be approximately 26.6 degrees. Okay, so anytime you're going to find the angle, you're going to use that second button on your calculator to access the operation that is just above the sine, cos, and tan. Because I'll say it again, sine, cos, and tan would take an angle and produce a ratio. That's, by the way, that's why each one of these looks like this. That's why each one of these things looks like this. I've got the sine of A equals the ratio. I've got the cosine of A equals the ratio. I've got the tangent of A equals the ratio. Sine, cos, and tan produce ratios. You give it the angle, they produce ratios. If I want to go backwards, I need that to the -1, to the -1, to the -1 to go from the ratio back to the angle. Okay, so that's one way of finding the acute angle inside a right triangle. Okay, well, another way that you can find an angle in a triangle here is to use that interior sum, kind of that idea that the angles inside a triangle always add up to 180. Now, in this particular case, the reason why that is so useful is because you will normally be working with a right angle triangle, which means you will already know that one of the angles is 90 degrees. Okay. So if you're given another angle, so if I'm telling you that this angle here is 36, well, it's quite easy to find that missing angle here. Angle B is going to be 180 degrees, the whole triangle, minus the 90 degrees for the right angle, minus the 36 degrees that was given to me. Okay? And then you could get 54 like that. Now, there is another way of thinking that thing through here. I could redo this and just realize this, that 90 here is half of 180. And in fact, anytime I'm working with a right angle triangle, I'm going to have this little term right here present in this calculation. So this is always going to be 90 here. In other words, I can shortcut that, and I don't have to write 180 minus 90. I can simply write 90 minus 36 degrees, and that would give me 54 degrees as well. So what I'm doing here is I'm focusing my attention on just these two. As long as there's a right angle up here, these two angles right here also have to add up to 90. Okay, these two have to sum to 90 degrees. So that's just another way that you could go about doing basically exactly the same thing as we did previously, just taking a little bit more of a shortcut about it. Okay, so now to kind of wrap this up, this discussion right here, if the triangle has two given side measurements and only a 90-degree angle here, now what are we going to do? Well, okay, first of all, step one, we're going to find the reference angle. So the angle that is to be calculated is called the reference angle. Again, we've talked about that already. You know that. And we usually are going to use the theta to represent that, unless they've given it another name. If they've already called it like X, or they've called it angle A or whatever, that we'll leave it. But if they don't, we're going to call it theta. We're going to label the sides using relative labeling. So it's, remember, that means relative to where theta is. And so that's going to be your opposite, and I'm going to write this out here, your opposite and adjacent. Now your hypotenuse, well, the hypotenuse is the hypotenuse. It's going to be the same regardless of where the angle is, because the hypotenuse is always going to be opposite the 90 degree. Then we're going to choose a ratio. So basically that ratio is going to depend on the two sides, the two known sides here. And so we're just going to pick the ones that match up. So if we, for example, if we know the opposite and the hypotenuse, well, that's going to be sine. On the other hand, if we know the adjacent and the hypotenuse, that's going to be cosine. But let's say we don't even know what the hypotenuse is. Well, that gives us the tangent ratio. And then we're going to substitute those side lengths into the ratio and use that to evaluate. And then to find the second angle, okay, sorry, not to find the second angle. To find the angle, I just saw that second there, and I don't know why I popped that in there. To find the angle, you're going to use the second function on your calculator. And remember, we were talking about that just a few moments ago. We're going to use those functions right there to convert the ratio. It converts the ratio to the angle. So let's take a quick look at some examples here. And they're not all going to be of this. You'll see in just a second here. So take a look at this first one here. Let's call this question mark here. We'll call that theta. And so based on that, I know, first of all, I know that this is going to be the hypotenuse. I know that way over here on the other side, this is going to be the opposite. And because this side that's 29 is used to make theta, that and the hypotenuse, theta is between that side and the hypotenuse, that's the adjacent. So I don't know the hypotenuse, but I do know the opposite, and I do know the adjacent. Okay, so because I don't know the hypotenuse here, this is a tangent. So the tangent of theta, that ratio would be the opposite, the 20, over the adjacent 29. And then to get that theta, I would use the inverse, or the second function tangent of 20 over 29, plugging in that ratio. And when you press enter, you'll get approximately 34.6 degrees. Okay? And that's how you do it. That's the pattern that we're going to want you to follow here. So for example, here's my theta in this triangle. There it is right there. I'm going to use relative labeling for this one, except I know that right here, this is going to be the hypotenuse. I know that the 7 here, because it's being used with the hypotenuse to make up theta, this is going to be the adjacent. And over here, way over here, this is going to be the opposite side. And I don't know what that is. So I do know the hypotenuse is 8. I don't know the opposite side, but I do know the adjacent, that was equal to 7. So then what trig ratio doesn't use the opposite side? Well, that's cosine. So the cosine of theta is going to equal the adjacent side divided by the hypotenuse. So now on my calculator, I would do the second function, cosine, and that's going to get me approximately 29.0 degrees. Now, for this last one, notice that I don't, okay, I should say it like this, I don't need, I should say it like this, I don't need the trig ratios here. I don't need them because I know that these two angles here should add up to 90 degrees. Now, I know all the angles in the triangle add up to 180, but I know that those two angles should add up to 90, okay? So my question mark here, or my theta, should be the same as 90 degrees minus that 40 degrees that I'm given. And so I know that theta is equal to 50. So it's just a matter of adapting to whatever information that you've been given. Okay. And I hope that gives you a little bit of confidence moving forward with these ratios here. Now, there's still a whole lot more to cover, but this is a good kind of a good grounding to get you started.